We already built a time series model based on transformer.
Yep. Toto.
Yes. And what's fascinating is that, so it's a model that we built for observability. So we built a benchmark for observability data. And when I say time series, it's numerical data. And the goal is really to predict what the time series are going to be, over the next, minute, hour, day, month. And we use that for anomaly detection. Basically, we compare, what the prediction is versus what the reality is. And this is the first model we built internally on transformers and deep learning. We built it with our own data, focused it on observability data. And what was kind of shocking to us is that this very first model is state of the art for all of time series. So it's better at weather prediction than the non-observability time series model. What it tells you, in addition to, hey, the people who have on it are probably pretty good, what it tells you is the quality of the data makes everything, because we have so much of it and we have so strong signals about its quality. Like, not only do we have tons of time series, as you can imagine, we ingest billions of records per second, so that's a lot of stuff we can look at. But we also have very strong signals about what people actually use to get woken up at night, what they look at, when they look at issues. So we know which signals are particularly strong, and we can weight that in the training of the models.
Olivier, we're so excited to have you on today. You've built a legendary company. Datadog has become the name in modern observability. I used to rely on it all the time in my operating days, and now I have fewer incidents, at least technical ones, as an investor. And I'm also excited to be co-hosting this Barchives with Sunil, which just makes it so much better. You two go way back and have a long history.
Yeah, Oli, it's great to see you. I mean, 15 years plus ago, it was a very different view in the background behind you, but it's fun. I don't think we've had a chance to do one of these together in a while. So great to see you.
Thank you. And yes, I think it looked more like a basement at the time, but yeah.
And now you have the beautiful New York view, or depending on sometimes the Eiffel Tower view. We're here today to talk about AI at Datadog. You two have a lot of history. Before we dig into everything you're doing with AI today, I thought we could sort of zoom out and take a trip down memory lane. So Datadog was born out of the last major platform shift from on-prem to cloud, and it scaled alongside the cloud giants like AWS. Today, I don't know how much you hear this, Sunil. I sometimes hear the narrative that foundation model companies will do it all and capture most of the value downstream. It's a little bit less common of a narrative today, but certainly a few years ago. So I'm curious, if you look back at how the cloud era played out, do you have any lessons to apply to builders building on top of AI agents and foundation models in the AI ecosystem today?
Yeah, the thing that's interesting is that we didn't even start with the cloud in mind. Like, the idea behind Datadog, the pain we had was about developers and operations not working well together, and living in separate worlds, separate tools, separate everything, and basically finger pointing all day long. So we started a company to change that, and it turned out that cloud was the entry point, and it also turned out that to be successful in the cloud, like, you really need to bring Dev and Ops together. Like, actually change the role of Ops quite a bit. And a lot of the savings you could make and the improvements you could have as a company by moving to the cloud were about collapsing what was two separate teams and a very long cycle to ship value that, from that time was very was much tighter. So it was not about the transition. The transition was the insertion point. And I would say also there was a fear at some point, like, if you go way back into the days of the cloud, at some point there was a fear that Amazon would run away with all of it. We could have thought that, hey, maybe in 15 years we all work for Amazon. It hasn't happened.
I mean, I think this was the topic at many reInvents, right?
Well, it was a topic, I think, in many, like, when you used to show up at those events wondering what else they were going to announce that was going to put companies out of business, and there was no credible alternatives from Google or from Microsoft at the time. So it was very much a one-player game. And I think you could argue that you had the same dynamics maybe last year with some of the foundational models and things like that. I think today it looks much less like it because there are many credible alternatives, many credible vendors, there's specialization in all parts of the stack pretty much. But I would say it's still very early. So I would say my free advice to anybody starting a company is when you see a very, very thick, stack to deliver value, it's much better to be on the ends of it, like where you're in touch with the problem or the customer, rather than in the middle of the sandwich, where you're going to end up is a lot more difficult to predict.
Makes sense. Yeah, I think starting with the problem, and then there's tailwinds from EC2 launched in 2006, Datadog in 2010, and there's ChatGPT now, and there's a lot of companies that are growing very quickly. Datadog, observability company, helps folks monitor their applications and infrastructure. You had a business, you still have a business that's really, really working. I'm just curious to understand at what point you realized AI was something to take seriously and that you wanted to invest in, not just, a cute checkbox or marketing, but the real deal. If you have, I'm putting words in your mouth, if you believe that.
Yeah, no, what's interesting is that, so AI, so to speak, was there from the beginning, but in the very early days, it was a bit of a curse word. So when we started the company, there had been maybe decades of companies in systems management and that were promising the wonders of AI and solving all the problems for you because the computer is going to do it. And in most cases, it was not AI at all. In fact, there's even a category, or there used to be a category that was called AI Ops, like a category in the sense of a Gartner category, like what for which you have a Gartner quadrant, who's winning, et cetera, et cetera. And that there was no AI in any of the products there. Like what they called AI was basically rules with regular expressions. Sometimes you'd get additions and divisions, but that was as far as the AI went. So early in the life of the company, we decided we are not going to plaster our website with claims of magical AIs, and smarts in the cloud that would solve everything for you. But in the back end of it, we had to do quite a bit of what was then AI, which was let's call it classic machine learning, to understand what data to keep, what data not to keep, what to surface to the end users, how to detect anomalies, that sort of stuff. That you absolutely have to do for observability at scale. Things started changing quite a bit with ChatGPT. That's when the whole world stepped into the transformers and LLM AR. And then we saw a whole bunch of new opportunities open up. So all of a sudden, one, you could use all of the natural language data that was out there. Before that, it was kind of a little bit off limit. So you were not limited to some numerical algorithms. Basically, in AI, you could open it up quite a bit more. You had the ability maybe to start doing some reasoning, and stitch different parts of the process together. And also, you could extend, or you could understand how to extend the transformers model to other types of data. So maybe some more numerical processing, but that could be a lot more efficient with transformers and deep learning than it was with classical ML before. So we started doing a little bit of all of that. And we also switched to a world where instead of AI being a bit of a bullshitty buzzword that you'd find in healthy servings everywhere over the net, like it actually became something that was real with a real potential impact. Now I think we have to be a bit careful, to make sure that it's not used too liberally, so we don't end up with another big cool down of the market where it doesn't work as well as people imagine it will, and folks are disappointed, and then you end up having to stop saying AI. My guess is it probably won't happen. It looks like we're progressing fast enough, in terms of everybody delivering of the promises that are being made. But we'll see. I'm optimistic.
So you said everyone had this aha moment, including, you can use natural language and data, you could use transformer for potentially other modalities. What does we actually look like? So you have this business that's working. How do you commit to exploring this? How do you form an initial AI team? Like, what is the origin of that coming together? Is it top down? Is it bottoms up? What happens to make it happen?
Well, there's a little bit of everything. So first of all, there's the existing ML team that is moving into the next generation of AI.
Got it. So this team already existed and was focused on sort of this older version of ML that we talked about, and now they said we have to pay attention to this.
Yes, and some people in school maybe they had learned about transformers and things like that because it was already out there. But the big success stories hadn't emerged yet. I mean, you had the image recognition stuff that was getting pretty popular already, but there was a lot of areas that were unproven and explored. So a lot of it came from the existing teams initially, and I would say that when you look at what we have today, that's probably the part of our business that's more applied AI. So which is we take all of those pieces of research that are out there, these known algorithms, and we apply them, we tune them for the use cases we have, and then we have engineering teams on the back of that actually build products with them. We also later on we started building an AI research team. Where the focus is more on, so now we're going to look at novel research, and we're going to build our own. And it's quite fascinating there. If I can take a quick digression. So I actually started my career in research. So what brought me to the US was a job at IBM Research in upstate New York, which at the time, I'm going to date myself now, but at the time it was pretty cool. At the time it was where research was happening. It was before Google Research, before Meta, before all of that stuff. And when I started my career in research, it would take 10, maybe 15 years for research to turn into products. Maybe, like if it ever turned into products. Like mostly the stuff that was produced in research resulted in patents, but not a lot of applications. If you look at what's happening now for the cutting edge parts of AI around LLMs and reasoning and some of the related processing, the research is turned into products within 6 months, and it's not published, meaning you have to have your own. So you can't just rely on the existing research, which is why we started that team.
Interesting. Oli, when you guys put together the AI initiative or it came together, did you feel like this was more of a product and research internal-led drive, or was this in response to things your customers were asking you to do, and you said, we need to get there faster or better than we've been doing it today?
Yeah, it's actually a bit of a switch from what we had been doing before, because for the whole life of the company, we've been able to rely on very, very clear customer demand. So we either looked at existing categories, or we looked at things the bulk of our customers were asking on top of our existing products. And so we had really, really good signals about what exactly was needed to solve what problem in what way, and what the alternatives were, and what was going to be good enough. For AI, there was a high level expectations from customers that, hey, AI should do that for us. But the that and how and what good enough means, all of that was completely unclear. And so for when we started building for AI, and it's still today, we have to build more speculatively. So we have to get a little bit ahead of what we think the market will bear. And then we figure out what actually works, what doesn't, when we ship to customers and when we see how they use it. And by the way, between the time we start building and the time we ship, the world has also changed quite a bit. There's new models, there's new things that look like they were going to work are probably not going to work anymore, and others that looked out of reach are not very possible. So I think you have to, we and everybody else in the space has to iterate very quickly.
Well, I think where you sit in the stack also means that your manifestation of AI is going to look very different than other people. You are not a pure end user application, nor are you a foundational service that people kind of build around. You are clearly still, Datadog it's tools for people to do their work better, tools for people who are developers and engineers and operators to work. And so that, I have to imagine, is also very different in the kind of experiences you need to think about delivering to people. They can't tell you, this is an application I have, make this AI enabled, or here are the primitives I want you to give me to go power these other things. You have to focus on making their life better and making kind of complexity disappear more than you have to give them some brand new shiny capability a lot of times.
Yeah, and you have to discover really what good enough means, because the problem with AI is that we don't have a good mental model of what is supposed to work and what is not supposed to work. Or rather, that model that we all trained for the past 15 years doesn't work anymore. Like overnight, what was supposed to be incredibly difficult, which is to converse with a machine that speaks better than any human and understands anything a human can produce, that was impossible. And then overnight, it became the easiest thing in the world. And I think it completely warped our understanding of what should be hard and what shouldn't be. And as a result, because the machine is so good at presenting the results, we imagine that it's very, very good too at processing everything on the back end, which is actually not the case yet.
So let's actually talk about that because, you mentioned that some of this is staying ahead and trying to anticipate and then seeing what actually resonates with customers. So how are you using AI today? And what is resonating most with customers? So I know that, like Bits AI spans SRE, dev, security roles. What concretely are the use cases that customers care about the most that you've shipped into the world or that you're working on?
I mean, so first of all the stuff we used to do, we still do, right? The anomaly detection, the algorithm that run on every single data point you send us or customers send us, like that is still there. There's a number of things customers want us to automate now. We mentioned we have an AI SRE, which basically looks at whenever an alert fires, it goes and looks for the root cause for it, and it explores the field of possible. It looks at all the data it can, and it formats an answer for you, so it tells you exactly what the root cause is for it. It used to be fairly hard to do that. Like you had to build these systems in a way that was very rule based and sort of brittle. And I would say the precision on those was pretty low, in general. And now you can actually do a lot better with that. So we also have another part of the agent. I mean, it's all branded the same way. It's all Bits AI, but we have different agents under the hood that are specialized for specific use cases and trained with specific data and evaluated with specific data sets also, and they can communicate. So we have another one that does that evaluates security issues. So it will look at security signals, such as people logging into different applications at the same time, and then it will try to decide whether it's an issue or it's benign, it's a normal behavior. And what's interesting is that both are understood by the customer in a similar fashion, which is, hey, something's happening, and the machine is going to do part of my job, which is to understand, what's happening. But the constraints in terms of what good enough is are actually very different. For AI SRE, for example, the most important is, so first you need to have breadth, so you can look at pretty much all of the root causes possible for an incident, and make sure you find the right one. And then you need to have very low latency, because it's an incident. If it takes you longer to figure out what's going on than the humans, then that's not very useful. So you have a strong latency constraint. If you flip to the AI SRE, latency is not all that important, because chances are you're going to look at a string of events. Maybe you'll have minutes or maybe hours to even sometimes to do an analysis. But the one thing that is very unsettling for a user is the stochastic aspect of an AI agent. For example, if you look at the same issue twice, and if once you say it's okay, and after that you say no, actually no, it's bad, then that's a big problem. And so there, the question is precision, of course, but also the stability of the precisions you make, so you don't lose the trust of the users.
Oli, when you think about the evolutions of how ops and dev have tried to do their fundamental roles and sec over time, we've gone through DevOps and it's turned to chat ops and then Slack ops. Is the idea of AgentOps or AI ops a real thing? Like, is that something that you actually imagine for your customers, that what they will be getting is systems like a chat interface or a natural language interface, or agents that will act instead of just being asked to act, as the foundational element of how ops gets their job done? Or is that not the Datadog vision of the future?
I think it's going to be I would say two things. One is, I don't think we can predict what the form factor of applications in general is going to be, 5 or 10 years from now. I think the exact boundary between language and UIs and proactive, reactive, I think is still unknown. Like, we will have to test, what works, what doesn't, and there's probably new innovations that are going to help some things, and we'll see. I mean, we see today already the limits of chat-based. Mostly that is that folks don't know what to ask. Like, you give them a prompt. It's actually when the whole world is at your fingertips, you don't always know exactly where you want to go. And you see also, like, for example, the car manufacturers that are starting to re-inject, hard buttons into their car dashboards instead of just touchscreens. because their customers, their users like to have muscle memory of where things are and know how they can do the basic operation of the cars, basically. So I think there's going to be quite a bit of exploration in terms of what works and what doesn't. And some of that I even see like a form of scientific discovery, because you just discover the form factor that works, and you try 7 of them. They look good for different reasons, but there's just one of them that sticks, and that's just a fact that you found out, and then you build on top of that.
That feels very different than the Datadog approach to product development or delivery historically, because if I was to characterize from the outside looking in how you guys have done product development delivery, it's a very good understanding of what customers want and need, but a very core belief that no matter what capability you want to give them, you want to give it to them through a single and common experience that works with them across all of their applications. And your business has seen the benefit of what it looks like when people understand how to intuitively get their way through the next bit of functionality you give them. What you're talking about in terms of that exploration of maybe changing what the interface looks like, or changing even just the whole way in which you'd interact with a service like Datadog, that seems like it could introduce a bunch of uncertainty in that pretty certain dynamic you've had today.
Well, I think it only looks certain from the outside. We had to try lots of different things to make it work, and we keep doing that, especially as we've added more products and more different types of users. And internally, it's probably been more tumultuous than the beautiful straight line it looks like from the outside. I think, by the way, I still believe in super consistent, super integrated experience. I just think that the form factor for that experience is going to change quite a bit, and there's certainly going to be a lot more free-form interaction. If only one thing we shipped, for example, at our conference a few months ago is like a voice mode for incidents. And it's a voice mode with the most modern like voice technology, which is kind of full two-way. You can interrupt the machine anytime. It responds right away, and it's kind of transformative. Like for an ops alert use case where you're on your phone, you're outside, you don't have your laptop, and you want to be able to ask a few questions very quickly, give a few next steps very quickly, and have the machine do all of that for you. That's actually quite transformative. It's likely not how you'll do the whole problem solving, because when you're a human, you're probably fairly visual. You want to go look at things. You want to build some understanding of what's going on. Have a higher bandwidth form of interaction with the software. But there's going to be a mix. Maybe you'll be at your computer. Maybe you'll be typing commands. Maybe you'll be also asking questions verbally at the same time with your own voice. And all of it is going to be mixed together by the machine. I think it's going to be fairly fascinating, actually, in terms of how that interaction can come together.
Yeah, I saw that. I mean, what I love about the voice mode is you kind of go as far as you can or you want to with voice, and then it leaves you, or it brings you to the screen post-voice that you actually care about. So how do I continue? I've done all the things I need to do, or that I wanted to do via voice, and then I can just pick up where I left off. So I love that.
I was going to say, have you seen any interfaces that have either come out so far, or theories or plans that other people in the industry have put forward about how this goes that you just objectively disagree with? You're like, oh, that idea is going to take us in the wrong direction.
And maybe I'll add to Sunil too that right now, if you look at the code gen analogy, there's sort of one camp where you have the cursors of the world that are the popular IDE copilot for engineers, and then you have more of the Devon cognitions of the world that are autonomous software engineering in the background. So how philosophically you think about human as copilot versus kind of like autonomy maxing. 2 questions in one.
Yeah, well, I think those two modalities end up merging in the end. I think it's and then how much of one versus the other. I think all products will offer both, because you need to be able to let the machine work and do its thing. Is pretty clear. I mean, it's transformative in the way you build. At the same time, you also need a way to engage deeply with the output. Focus on a specific piece. Think about what you're looking at on the screen, and so you'll need to use both. I think how much of each you personally use is going to be a personal preference, and that's not new. Like when you think of how people build software, write software. There's so much personal preference in the tooling. I mean, they're still, I mean, the Emacs versus Vim wars, they're still going on, at least, with some of our employees, they're still going on. People have very, very strong opinions about how they want to work and how they want to manipulate all that. So I think there's going to be a few different ways of using the tooling there. And by the way, I don't think we even have explored all the modalities for that. I think we started with the copilots, which were kind of okay, but not really transformative. And we saw that when we had people adopt all that internally, like people were open to the idea, they wanted to see it, but the adoption was slower than we'd have thought initially, and the productivity gain was not obvious to everyone. And when we started adopting the coding agents, the adoption was much faster across the team. The effect was felt much faster. It felt transformative to absolutely everyone. And it's very possible that we have a third wave of that, next year with a slightly different modality that also ends up performing better. I should say, though, that the people feel better about it. I think it's still not completely clear whether or what the impact on the overall productivity is. I think it's really hard to measure.
Does it anecdotally feel like something to you, even if you can't measure it explicitly?
Exactly. I mean, anecdotally, it feels great, and it feels, we have all these signals that say it's going to be great. There's no hard measurement that says, hey, we're 30% faster at shipping software now. And there was also this study that we went around, I think, a couple of weeks ago on, on open source software. They had found that, the people felt 20% faster, but in reality, when you measured the task completion time, they were 20% slower. So, and by the way, I don't know if that's really sound at all. Like, you can read this thing and its opposite, pretty much all day long. But I think it will take a little bit more time to understand exactly which of those practices contributes how much of a productivity gain in the end. But to me, it's completely unavoidable that we see immense productivity gains, and we can really multiply the output of every single engineer.
I also think that part of that is like it depends on your workflow, it depends on your task, and each of those things could be very much rate limited by different problems we've yet to solve on the AI adoption journey. I mean, some of these problems are still very much limited by the power of the model or the power of the transformer to actually make an accurate prediction and deliver them some insider knowledge that they couldn't before. But other things, I'm sure the models and the tools are all good enough, but we're stuck on elements of workflow and elements of interface and things that actually let people do the part that approximates their job. And I think each one of these things as to whether or not how productive you are is going to really depend on which particular bottleneck you're facing and what the vendors that are trying to solve those things for you actually go off and focus on.
Yeah, and my belief there is, by the way, that in the end, it won't surprise you. I believe it's an observability problem, and the reason for that is the models are very good at generating code, but the bottleneck is verifying what works, what doesn't work, if it works fast, if it does what it's supposed to do for the business, which is, you ship a feature because you want more conversions, more retention, more something. And all that is gated on shipping the software and watching it run and measuring what's happening. And I think the future of software building will go through better interfacing with production and end users so that you can test and validate a lot more easily. And that's the part of the equation we've been focusing on the R&D side on our end. Part of that by figuring out how we plug into all of those coding workflows and existing coding models. And part of that also in building all of the machinery it takes to ship and test and watch and validate the code that is being running. So part of it, for performance, we profile everything that's happening in production. We can tell whether a specific piece of code is slower or faster. For correctness, we have synthetic testing and we have error tracking in ways to verify that the code is actually working. For business impact, we actually acquired a company you know very well in the A/B testing and experiments and feature flagging space. And the plan there is really to help that.
For those watching, that's EPO, founded by Chetan Sharma, as an Amplify portfolio company.
And the plan is really to turn that into the machine that can be used to continuously validate what the coding engines are producing. So if I think of where we are as a company, we're not trying to go and be the cursors of the world or the Claude codes of the world, because I think these are going to exist very much on the dev side of things. And they have a huge mountain to climb in terms of building the models for that and the user interactions, and going from product description to requirements into code. We're focusing on the other side of that equation, which is what's happening in production and how can we not just serve the developer with 20 potential fixes that they should implement, but tell them which one of those fixes is going to work, and tell them we've tested it. This is the impact on performance, the impact on correctness, the impact on the business. Do you want to validate or not?
What's the biggest technical challenge? We talked about a lot of different AI-centric problems, and Sunil brought up, some of this gets better as the foundation models get better. What do you view as the biggest internal technical challenge or hypothesis that you have to make Bits AI and all of your AI offerings even better?
Well, there's two parts to it. One part is, and that's something we're used to, is that there's a lot of moving pieces to make this work. You need to build code, you need to ship code, you need to go and test it live, you need to have safeguards, you need to have, you need to instrument pretty much every single runtime in the world. You need to, it's very easy to make a demo of that, but to come into the real world and make it happen in an environment that is diverse, has all sorts of things running, all sorts of constraints with end users, that's extremely difficult. And so a lot of it is building that. The second part, which I say it's a bit newer, but is the same for every single AI company, is, a lot of it is in the data. And in particular, what you use to train the models you have, and what you use also to run evals. And even if you don't train a model, even if you use models inside something, you need strong evals, and the evals are gated on the amount of data and the quality of the data you have. And we found that, for all of the AI products we've built, usually things start very impressively at the stage of a demo, then they go sideways for a bit, and then the moment you actually have good evals, they start improving very, very, very quickly.
Who's in charge of evals at the company? Is it kind of per... do you have a centralized AI team? Is it the domain experts in their certain product areas? Is it something else?
All of the above.
All of the above.
And we go through that pendulum swing on a regular basis between centralized and decentralized for those teams. And I think there's value in both. By the way, I don't think one is superior to the other. And I think it's healthy to switch from one to the other, because every time you do that, you shake the pieces a little bit. You get rid of what's not working so well. You retry certain things in a bit of a different way. And then invariably, a year later, you figure out that there are some limitations, and then you start, swinging the pendulum the other way a little bit.
Maybe the flip side of it is, so some of it is the improvements come from your own data, and then some of it, which we talked about earlier, is the models get better. If you could wave a magic wand and get the models to do something that they're not doing for you now to improve in some way, is it obvious to you what that would be?
Look, models having a high level of confidence on what they get and what they don't get would be amazing, but that's extremely hard and quite unlikely to happen. I would say that the most important thing I would ask for is much better latency across the board, because that solves so many other issues. You can, even the issue of stability and the stochastic aspect. If you can run the model 100 times, yes, it's more expensive, but if you can do it in a way that is still usable, and doesn't take that much longer to run, you can actually improve the answers quite a bit.
Well, you mentioned a pretty interesting point, which is, obviously on lots of the predictions and the analytical work that you would look for AI to do for you, determinism would be ideal. But the reality is lots of what gets done in observability is still statistical analysis. There's still plenty of sampling. There's still plenty of after the fact trying to deconstruct things, not based on ground truth, but based on the exhaust and the evidence of what's left behind. So when you think about applying models that are inherently not deterministic to observability problems altogether, what are the parts that you look at and say, here's where we really lean in to take advantage of what it can do, and it's in the nature of these problems we're really going to lean on it, versus it's these other things where it's just not the right tool for the job, and we've got other techniques that we're going to keep relying on, instead.
Yeah. I mean, you're right. I think a lot of observability is not completely deterministic. And anyway, the picture you get is always imperfect. I mean, it's a picture at a certain second, and that picture changes second to second. So the issue of stability and the stochastic nature is not as big, because anyway, if you rerun the same analysis, 1 minute apart, you're expecting to get a different result. So I think that part is fine. Where I said it was more tricky was for security investigations, where you do want stability. So you end up building quite a bit more machinery, basically, so that you still get the beautiful, like the reasoning you can get from the models, the ability to explore, things that are not completely encoded in hard rules, but at the same time, have a high level of repeatability and precision, basically, on what you produce.
Cost of failure is also much higher.
I would say it's yes and no. I think in general, up to a point, I think in security, customers are more open to false positives than they are on observability. In security, if you shut down one too many VMs because you're worried something bad is happening, that's okay. If you wake up to people too many times at night for the wrong reasons in observability, that's not okay. People turn you off. So I would say the dial is set a little bit differently, though of course, I mean, like everywhere else, like if you generate too many false positives, you'll get in trouble.
Do you have, some of creating more not creating more determinism, but creating more bounds? Some of it is just better performance too. Do you have ideas beyond better evals of how to use this data to get performance better? Like there are certain, in coding, there's a lot of conversation around domain-specific RL. I don't know if these are areas that you're exploring or that you've thought about.
I mean, there's so many things. I mean, for one thing, that came from our research team, but we already built a time series model based on transformers. Yes. And what's fascinating is that it's a model that we built for observability. So we built a benchmark for observability data. And when I say time series, it's numerical data, and the goal is really to predict what the time series are going to be, over the next, minute, hour, day, month. And we use that for anomaly detection. Basically, we compare, what the prediction is versus what the reality is. And this is the first model we built internally on transformers and deep learning. We built it with our own data and focused it on observability data. And what was kind of shocking to us is that this very first model is state of the art for all of time series. So it's better at weather prediction than the non-observability time series model. And what it tells you, in addition to, hey, the people who have on it are probably pretty good. What it tells you is just the quality of the data makes everything, because we have so much of it and we have so strong signals about its quality. Like, not only do we have tons of time series, as you can imagine, like we ingest billions of records per second, so that's a lot of stuff we can look at. But we also have very strong signals about what people actually use to get woken up at night, what they look at, when they look at issues. So we know which signals are particularly strong, and we can weight that in the training of the models. So we built that. This one is open weight because it uses only our data, and we're building more versions of it that go beyond purely numerical time series. They're multimodal, though multimodal in this case means we mix time series data, so metrics, logs, traces, all the other kinds of metadata. And the idea there is the model has an intuition of what happens next when you've seen that log line and that piece of trace and that error in the database and that metric. You can actually get a pretty good idea of what's going to happen next. So it's fascinating because it works extremely well, and it's an area that the foundational LLMs they're not built for. They don't have that data, they don't have that training, they don't try to do that. And so there's a lot of ground we can cover ourselves.
Is there other places where you have where you feel like data as an advantage is something that you are you're able to compound more in because of recent product expansion or recent areas you've been pushing into? Where else are you getting data that's going to allow Datadog to do different things going forward from an ML perspective?
Well, everything that has to do with the application, so from the code that makes it run to the way it runs, so what's happening in memory and CPU when the code is running, to what the users are doing with it. What are they clicking on? Because we get the click stream also on the other end of that. And so these are the data sets we're using right now and that we're basically building models on. I would say though, on the coding model side and on the general LLM side, we don't do the pre-training ourselves. There's no point in doing that. The frontier models do that super well. It's quite expensive, not as expensive as it used to be, but it's quite expensive. And we probably are not going to do a much better job at it than they do. But we do quite a bit more in post-training, and I think that's a part of the ecosystem that completely exploded over the past year. And again, it's interesting to see how people are thinking. If a year and a half ago, very few companies were playing with post-training because it seemed that all the value was in pre-training anyway, and it was out of reach for most. And then you saw a few companies, some of the Chinese models, but a few others do amazing things, starting from scratch on the post-training side. And now it appears that actually there's quite a bit you can do. And that requires you very specific data, but you can go into places that the foundational models don't go to very easily, and you can build very specific value quickly this way.
Talent in AI is a problem for everybody, or maybe an opportunity for everybody. You're neither Meta in terms of how you compensate, but neither are you a startup. You're probably sitting in between the two in terms of your access to data and access to resources. How do you think about this from a building out your team perspective, what you need to be doing and what advantages you're trying to leverage in the this moment in time AI talent war?
I'll just add to that. How do you then structure it internally? Because we talked about research and Toto, but we talked also about evals and post-training. So I know it goes back and forth between centralized and decentralized, but any more color would help too.
Look, recruiting great engineering, it's always been like one of the most important jobs at the company, and that's something we've been doing for a while. So that part hasn't changed a ton. I think there's a bit more of there's a specific field which is AI research, which is a little bit different than the rest of the industry. But even there, we're not trying to hire the 10 people who did the last version of the GPT models or Gemini so we're not trying to do what Meta is doing, and I think that's a very specific part of the ecosystem that's quite out of reach for most companies now. Though if you want to be if you want to contradict that, you can also look at what's happening in China, and it doesn't look like they have to resort to any of that, and they're very, very competitive in what they can build. So I think there's more than one way to success there. One way we started the research team is we started by hiring a strong professor, a university professor to.
I was going to say, we love Amit.
Yes, and you Amit very well. Yes,
this is Amit is also a former Amplify founder. This is
yes, and I'm sure he told you that, but he was very close from being the third co-founder of Datadog in the very early days.
He's talked about that decision or the circumstances that made that not happen many times over the years that I've known him.
But he's and that's very key to getting good access to talent. Because when you're a top researcher, what you want to do is you mostly want to work on really interesting problem where you can have an impact and where it can be somewhat differentiated. If you're the 250th researcher to go after some part of optimization of the general foundational LLM training, your chance of having a huge impact is limited. Whereas, if you find a field that you're interested in, and when you can clearly like be state of the art and build what's the best, like that's a much better opportunity, and that's precisely what we're hiring for.
I mean, more concretely, one of the things that you said is that research doesn't look like it used to. It's much faster times of being put into product. It's not being published. So some of it is people are drawn to that. Like they want impact. They want it to go into product. They want it to touch real customers. So we talked a little bit about Toto, the time series foundation model. I'm a huge Wicked fan, and thus I like Toto the dog. And there's also BOOM, which is your public observability benchmark. How do projects like this influence product roadmap and customer outcomes?
Those started in research. So the thing is, with research, you don't necessarily start from a customer problem from day one. That's what differentiates research from applied, right? So you have to give research enough leeway so that they can sort of pick the problems. And by the way, that's where a lot of the new startups in AI struggle, because they're very often started by researchers. And they struggle to turn solving their own problems into solving someone else's problem, which you end up doing. You have to do in the end if you want to sell a product. And so that's a difficult thing. So those started as research projects, and then for those, the incorporating into the product is not very difficult, because better anomaly detection finds its use very, very easily in our product, and then it informs more things we can build based on the research, but that get closer to applied. When we think of hey, we can specialize the model in that way so that we can build this new feature that gets into applied, and then we have a straight path to serving the customer.
I feel like we've talked a lot about AI as a tool in Datadog, AI for Bits AI. We haven't really talked about Datadog for AI. So I want to make sure we talk about that too. What are you seeing from customers that are now building AI applications? What's different in terms of what they need for observability of their AI apps versus, traditional systems? Or maybe nothing's different.
No, it was super different is that the application is not pre-coded and pre-constrained, and the application, it makes it up as it goes. So you have to watch it carefully. That's and I would say that's true of the applications that are built around AI models, because again, those models are stochastic and usually fairly open-ended in what you can get in and get out. Even if you constrain that in your product, on the other end of it, the models themselves are fairly open-ended. So that's true for that. But that's also increasingly true for the apps that are written in code, because the code was not actually written by humans. And so the whole part where you spent a month writing these lines of code so you have a pretty good idea what the application does, that part is gone. So a lot of your understanding of the app is going to take place when you watch it, when you see what's actually going on. Is it working well? Does it look like it's secure? Is it saying anything stupid to my customers? That's the thing you'll have to keep watching. And I think that overall, there's more and more of a transfer of value between the act of writing the code and pre-constraining the application, and the act of watching it, tweaking it, and observing it basically in production environments. And that's why we spend a lot of our time on that side, on following what's happening inside the application.
How are you investing from a product and positioning perspective in this new AI app wave?
Well, there's a bunch of things we need to build around you. Like, for example, how do you watch a model? I think that's because the model changes so fast, and because also the applications that are built on those models are barely, for most companies, they're barely getting into production today. I think that space is changing very, very fast. We were talking a little bit earlier about building something speculatively. That's definitely a case or an area where we build speculatively, where we have to be ready a little bit ahead of the customers, and then we see what part fits the way customers actually build applications in the new world, and or what way the underlying layers are changing or not, in the future. So some things that used to be difficult maybe are not so difficult anymore with the models. Some others are emerging, and so that's a lot of that. For the watching the code produced by AI, and that's more what I was mentioning earlier. which is that you need to validate and you need to find ways to tie that back into the initial workflow that produced the software, and that's, I think that's quite a bit of work there. But it's interesting. A year ago, when I was asked the same question, I was focusing mostly on the applications running with models. But over the past year, we started writing so much more with agents. So now it might be that the biggest LLM-induced unpredictability in the application is not so much the model that you run in production, but it might be the fact that a lot of the code hasn't really been carefully written or read. Yes, it's been proofed, but it's not the same thing to spend 5 minutes on something as it is to spend 5 hours.
Yeah. And of course, when you have agents, there's just kind of cumulative errors. So you select the wrong tool, et cetera. And so that becomes a meteor problem too. I'm just curious personally, because I've heard from folks at Datadog that you're a very hands-on founder, like in an impressive way. Like we don't know how he has time to go into the weeds and like really understand. So I'm just curious, maybe why you stay that way. How are you personally learning about AI?
And from firsthand experience, I'd say it doesn't seem like it's let up after 15 years.
It doesn't seem like it's let up after 15 years, and I know you're hiring these super talented folks in AI, but like, how are you keeping all that context while running a public company?
Yeah. So first, maybe I just don't know how to do it any other way. So that's I don't know if it's a good or a bad thing. But look, I think I see it, by the way, very topically for AI, I see it as training the model. I think you need to feed from the real world data, which is what's actually happening inside our product teams, what's happening, what our customers are saying, what's happening in the deals on the sales side, what's happening in support tickets, so that you get a good sense of the reality, and you form good intuitions about what's happening. So that's personally why I stay in the weeds of many things. And by the way, I don't look at everything, right? I sample quite a bit, but that's the explanation. To keep up on AI, so one, I think two things. One is fascinating. Two, it's extremely important for what we do, so absolutely you have to do that. I do what I'm sure many of you are doing, which is I have a whole collection of newsletters, that give me homework every day, and I go religiously click on every single link, and I read, I figure out which ones I actually want to read, and at the very least, it gives me a good intuition of what's happening, and what's easy, what's not, and what seems to be the new direction and the new things I should pay attention to. I would say though, when I zoom out and I look at I read all those things about people who automate all of their work with AI. I'm still not at AI break-even. I still spend way more time learning about it than it saves me. So I'm hoping to get there this year. Maybe we'll see.
It's the upfront investment, and then it'll break through quickly.
Yeah, I even tried the notebook LLMs, but even that didn't work for me. I think it's still more easier for me to just scan the articles than to
I was
listen.
going to say, maybe that's good news for us since we're doing a podcast. Maybe just to wrap, like we talked about early, even if this wasn't the motivator, but on-prem to cloud, early observability, the future of observability. So kind of curious to hear where that goes, and how a lot of you as a person has stayed the same with respect to going deep and understanding all the different signals, technical, customer. So I'm curious how you've changed as a person and leader since starting Datadog, and what you think as you roll the tape forward, you may need to change in the future of observability and AI.
Yeah. So I actually have an expansive view on observability. I think the future of most future jobs are AI observability jobs. I think we all end up in a role where we have so much that is happening, and that the machines are doing for us, that we're here to watch what they're doing and nudge them and verify that it's happening the right way and they're doing the right thing, and that we get what's expected. So I think some of that will be at the level of the folks we serve today, which are the builders, the engineers, the scientists, that kind of folks. But a lot of it will be for what used to be the white collar jobs, So I think maybe you will not build an Excel model yourself, and maybe you will have the machine do that, but then you need some way to interact with it and understand what's going on, and that in a way that's a way to observe and correct and validate. So I think it's going to become more important as we get deeper and deeper into that. On the flip side, I think the form factors for the applications are going to change quite a bit. Many of the jobs are likely to change quite a bit. I mean, I don't want to be. There's many more people who can speak to that much better than me, but it's pretty clear that a lot of of day-to-day jobs will have parts that can be completely automated, and so we'll have to see what it looks like on the other end of it. So when you ask what who I change, I think I'm still motivated by the same thing, which is to build, and find hard problems and find ways to build. I think it's running a bigger company now. I think it's interesting because it's we have the means, to do things, build, hire people, try new things. On the other hand, we also have more inertia, like we have existing customers, existing businesses, existing employees also that need to move into that new world of building with AI. So it's interesting to me to see how to marry the two, basically, how we build the next thing while keeping the thing that made us successful.
Awesome. Well, thank you so much. This was amazing and really appreciate.
All right. Thank you.
Great having you. Thanks.
Great having you.